Hi, everybody. Today we're going to talk about scientific method, part 1, where you watch the video and answer the multiple choice questions about it. And then there's a second page on the worksheet where you apply what you learned based on Moby's experiment with his plants. All right, we're going to look at the second page now. So I will share mine with you. All right, looks like this. Now I'd like to draw your attention to this little screen over here, which shows you all of the slides in a Google Slides worksheet like this one. Page 1, page 2. So when you open one of these, look over here and see how many pages there are so that you make sure you don't just skip over one by accident, okay? As you can see, we have all these boxes here to fill in everywhere. All right, we'll start with fill in the table. Most of us use a loose form of the scientific method to solve everyday problems. For each of the problems and observations below, develop a hypothesis to explain what's happening. Then describe how you might test your hypothesis. We're not at the theory level yet. I don't know why they put that there. With a simple experiment. One experiment, we're not at theory time. We're going to look at the third one because historically, the third one has given people the most trouble. All right. The other two, once you've seen this one as an example, the other two should work pretty well. All right. So what's our problem? You're talking on your cell phone in your bedroom when suddenly the reception goes bad for a minute. Just before the reception, what do you notice? Just before the reception clears up, you hear the microwave beep in the kitchen. Remember last week when we talked about scientific process, we talked about observations, things you perceive with your senses or things you can measure. All right, so what can you perceive with your senses? Your hearing. You can't hear your friend in this phone conversation now. All right? But you hear a beep from the microwave in the kitchen, and now the phone call is working again. Do we know what happened? Maybe, maybe not. All right, might be something wrong with your friend's phone. Might be something wrong with your phone. All right, might be a problem at your friend's house, might be a problem at your house, and the problem might be the microwave oven was running. All right, that's an easy one to base on since you heard the microwave beep. Probably beeped because it was done. You could very well notice that you smell popcorn now too, okay? So what's our hypothesis? Okay, let's say that when the microwave oven is running, it interferes, oops, sorry, that's not right, with the cell phone signal. Right? Interferes with, blocks, okay? Jams, all right? I'll give you some blocks or jams. Okay, can't hear. All right, so that's what we predict. Can we test this? Yes, that's why it's not a bad hypothesis. You can test it. How would you test it? Okay, go into the kitchen. Call someone and start the microwave oven. Observe what happens to the reception. Right? Now you know that the microwave is on. While you're making your phone call, you see if you have the same problem. Was this just an unhappy coincidence because it messed up your call? Or is this really what caused the problem? All right? That's what we're trying to get with here. So I'm going to leave it up to you to deal with the cat and the air conditioner. Okay? In the first two problems. Want to know a secret? Microwave ovens heat food by producing microwave energy. Cell phone signals are made of microwave energy. So what do you think is going to be the result of this experiment? Good. I knew you would figure that out. All right. Order of events. All right. Identify the step of the scientific method each one is, and then number the statements in chronological order, 1 to 7. So I mean the first thing gets number 1, the last thing gets number 7. Okay, let's look at our choices here. Experiment, hypothesis, conclusion, inference, problem, observation, and results. Now we put all these things together up here, actually up here, when we came up with these ideas. They're kind of rolled in there, okay? So some of these are easy to figure out. What is going to be the last thing, for example? You can't form a conclusion until you've done everything else. So we know this is going to be number 7. Now we're going to try to make that look pretty. Up in the middle of the box. Okay. All right. Our conclusion is number 7. We know that. Okay. Where do you think you start? Well, let's look up here. You're talking on your cell phone when the reception goes out. Is that an experiment? Is it a hypothesis? Well, no, because we've got hypothesis and experiment there. It says right here, it's your problem. So guess what? Problem's number 1. Okay? That's where we start with the problem. Okay. Then, all right, we go to our observation. Something we talked about that you perceive. So you have a problem, and then you notice something that might be related to it. Okay, to help you figure it out. So that'll be step 2. Okay. Now, this goes straight to hypothesis because we cut out some steps here. All right. So you have a problem, you make this observation, you think about this a little bit, you make an inference. Infer, remember, like when you're reading, you make an inference, you figure out something that's not explicitly there. This is the putting 2 and 2 together here to see if you can solve your problem. Oh, it would be so nice if that was step number 4, but it's not. It's going to be 3. Okay. All right. So you have a problem. You notice something about your problem. You think you figured out something about your problem. Okay. Right? Especially if you start smelling popcorn right here. Now you can form a hypothesis. Which is a prediction that you can test. Okay? How do you test it? You do an experiment. Okay, and that box doesn't want to line up. Okay, your experiment. So we do this experiment and we observe what happens to the reception. It either cuts out or doesn't, right? That's something we can measure and report. Those are our results. That comes next. Okay? So those are our steps. We want to get rid of the green boxes. Maybe we'll just get rid of those green boxes. Okay, outline, transparent, there. Okay? All right, so now let's look what our choices are. We brought a block of unsliced cheese on the same day and it isn't moldy at all. We're looking for a problem, number one, right? On the same day as what? We don't know yet. That's probably not number one. I think that sliced cheese gets moldy faster because people touch it more. Is that a problem? I don't think so. I think. Which one of these words refers to thinking? Inference, right? All right, so that may be the inference. After 5 days, both sets of cheese that I touched are moldy. Both sets of cheese that I left alone have no mold. Okay. Sound like our problem? No. I keep 4 separate sets of cheese in the refrigerator, 5 slices that I touch once a day, 5 slices that I leave untouched, 5 cubes of unsliced cheese that I touch once a day, and 5 cubes of cheese that I leave untouched. This is an very good example of what it is. And I'm gonna let you figure that one out. Why is the sliced cheese in the fridge all moldy? Is moldy cheese a problem to you? It is to me. I think we found a problem, but let's read the rest of them. I was right. Touching is the critical factor in making cheese moldy. Should say moldy. Okay. Ooh. Does that sound like the beginning of the process? Does this sound like it's more at the end of the process? There must be something about sliced cheese that makes it more likely to mold. All right, I'm going to give you a few. All right. I think we found the problem right here. Why is the sliced cheese in the fridge all moldy? That's a problem, especially if you wanted to eat the cheese. Okay? Now next, observation. What's something else that you just noticed, perceived with your senses? You don't have to think about it. We brought a block of unsliced cheese on the same day, and it isn't moldy at all. That, my friends, is your observation. We're going to find out next week that this is one part of what I call research for the scientific method. Okay? Now, you put a little thought into it so you can do the rest of your study. And what are you thinking? What sounds like an inference? Okay. This could be it, but it's not. All right. Because there's a way to test this. Hint, hint. All right. There must be something about sliced cheese that makes it more likely to mold. Possibly. I was right. No, not it. I keep 4 separate sets of cheese. After 5 days, how do we get 5 days later already? No, we're still here on day 1 when we notice the sliced cheese is moldy and the unsliced cheese is fine. So if that's true, then I would say there must be something about sliced cheese that makes it more likely to mold. Nobody's telling me that. I just figured it out myself. But based on my observation, that's my inference. The rest of it, I leave to you. Okay? If you have any questions, you can contact me here in Google Classroom or on Remind, and I'll be happy to help you out. Okay? So good luck completing your assignments. It's especially during this makeup week, the last week of July. I look forward to getting all sorts of good work from you. All right, take care. Bye.